Part A. Find the binomial expansion of the square root of 1 minus 8x, where the modulus of x is less than 1/8, in ascending powers of x up to and including the term in x cubed, simplifying each term. So binomial expansion formula, you get given it in your formula booklet. It looks like that. So I need to rewrite my expression as 1 plus x to the power n. So instead of the square root, I'm going to rewrite this as 1 minus 8x to the power of 1/2. So to use the formula, I've obviously got the 1 at the front, which is good. My x in this case is actually a minus 8x, and my power, the n, is actually 1/2. So using the binomial formula, I've got 1 plus n times x plus n times n minus 1. So 1/2 take away 1 is minus 1/2 divided by 2 times 1. And then I've got the x squared. And then we do need to go up to the x cubed term here. So we need one more. The next number in this sequence would be n times n minus 1 times n minus 2. So we need to take away another 1 now. So that's going to be a minus 3 over 2. Over 3 times 2 times 1, which is 6. And then we've got the x cubed. Right, we need to simplify this. Right, so let's go through this term by term. So obviously we've just got a 1 at the front there. Then we've got 1/2 times minus 8x. So that's minus 4x. 1/2 times minus 1/2 is minus 1/4. Divided by 2 will be minus 1/8. Which is then going to be multiplied by minus 8 all squared, or rather minus 8x all squared. So minus 8x times minus 8x will give you plus 64x squared. And we'll simplify that in a minute. 1/2 times minus 1/2 times minus 3 over 2. So the two negatives will make a positive. The 1 times 3 will be 3. And then the 2 times 2 times 2 will be 8. But then that has to be divided by 6. So dividing that by 6 will actually be 3 over 48. Or 1 over 16 if you prefer. I'm not finished simplifying yet though, because we still have to do the minus 8. The minus 8x times minus 8x times minus 8x, which is going to give minus 512x cubed. Right, so let's finish off this simplification then. Obviously the 1 and the minus 4x, they can't be simplified anymore, so we'll just copy those first two terms down. But then we've got the 1/8 times 64, which will just be 8. So we've got a minus 8x squared. And then we've got the 3 over 48 multiplied by the minus 512, which gives minus 32 x cubed. And so this is, I'm saying the square root of 1 minus 8x, the first 4 terms of it are given there. So that's my answer for part A. Part B. Show that when x equals 1 over 100. The exact value of root 1 minus 8x is root 23 over 5. So if I substitute 1 over 100 instead of x here, I should get this. I need to show that. So the square root of 1 minus 8 times 1 over 100 would be equal to, well, 8 times 100, 8 times 1 over 100 is 8 over 100. Let's get a common denominator here, so we're going to times this by 100. And so we can see that this is going to be 92 over 100. 92 over 100, we can divide top and bottom here by 4, and we'll get 23 over 25. And we can't square root the 23, but we can square root the 5 to get 5. And that's what we needed to show. So we have shown that when we substitute 1 over 100 in here, we get this. Part C now says to substitute 1 over 100 into the expansion and hence obtain an approximation for root 23. So let's substitute 1 over 100 into our expansion first of all. Let's do. Need that. Okay, so we're going to do 1 minus 4 times 1 over 100 minus 8 times 1 over 100 squared minus 32 times 1 over 100 cubed. So if we substitute that in, we get 0.959 168. I know it says 5 decimal places here, but I'm writing 6 down because I'm not finished. Because this is not an approximation for root 23. All I've done so far is substitute 1 over 100 into the expansion. So I've substituted 1 over 100 in here. And in part B, we showed that when we substitute 1 over 100 into here, we get root 23 over 5. So what we've actually just done here is found an approximation for root 23 over 5. We have not found an approximation for root 23. But that's fine, because all we need to do then is take what we've just got and multiply it by 5. So 5 times 0.9595168. And we now get our actual approximation for root 23, which is 4.79584. And that is our actual approximation for root 23, which should make sense because you can see it's just below 5, which is what we'd expect for the square root of 23.